There are trillions of bacteria that live on and in us, based on every surface of our body, like our skin, our gut, everywhere. And they basically aid us in all these processes that our body is incapable of doing on its own. And so to better figure out how to engineer our microbiomes, we want to figure out what are these driving forces behind the colonization of these various surfaces. So basically, a lot of the current research provides snapshots of our colonies, our microbiome, and we just know what is there, but we don't know how it gets there, or why it gets there, or how it changes over time. So we want to take a look at these driving forces, and we're focusing on the skin because it's very easily accessible. I mean, it's right there. So it's very easy to sample, and we can get very fine-scale spatial resolution to figure out what these forces are. So what I'm doing right now is optimizing a sample processing pathway. So this is very necessary because I need to figure out what is there, first of all, and figure out what are the components within each of these colonies. And so this whole pathway is being optimized at the moment, but basically it will end in DNA sequencing, so we can identify which of these strains are present. And then once we do that, we have all this data to play with, and that would be a lot of fun, and we can figure out what is actually there and figure out what the forces are. For future, over IIP and over January, I plan to start the actual sampling process with actual human subjects and real life pores, and it will be really cool. And so basically once we start that fine scale sampling process, we can figure out what is growing there, how they're interacting with each other, how it changes over the distance that we sample at, and using that we can figure out what forces are at play.